Hi everyone, welcome back to Grade 12 Maths with Mr. Simons. We make maths simple and try to get your exam ready. Alright, in today's lesson we'll be looking at trigonometry in 2D. This is introduction to trig ratios, and we're going to do some examples to show you how we answer these questions, but at the same time in the next lesson I'll do a video so that you can see where does trig ratio originate from and where does it come from. Right, because after doing this, some of you will ask me, how did we come about this and that, which normally happens at school. Alright, so let's look at the first slide. So, what are trig ratios? Trig ratios, in short, I assume you still remember ratios are similar to a fraction, 1/2, or saying 1:2, etc. These are special relationships between the sides of a right angle triangle, you see there? Triangle with 190-degree angles. Alright, so these ratios, or trig ratios or trigonometric ratios, helps us find missing side lengths or angles using only a calculator, no ruler needed. So we don't need to physically measure. That was the old school, they physically measured. Right, now we can just use a calculator and use the relationship of the trig ratios to find the opposite sides or their angles. So my three basic trig ratios that you need to know and you should have been introduced to already to. First one, sine theta. So although there it's written sin, it's actually pronounced sine. We just drop the E because it is actually sine theta. That there will always be the opposite side over the hypotenuse. So if theta is here, we go opposite that angle. You see there's theta. We go opposite that angle. And the hypotenuse is always opposite the 90-degree angle. So opposite of hypotenuse would be sine theta. If I said cos theta or cosine theta, the complement of sine, then yeah, cos would be adjacent, what is next to the angle, over the hypotenuse, right? So adjacent will always be next to the angle, and the hypotenuse is always opposite the 90 degrees. So cos theta is adjacent over hypotenuse. And then tan theta will always be my opposite over my adjacent. So there, theta opposite the angle, adjacent. Opposite over adjacent gives me tan theta, or mathematically actually y over x, also called gradient. But we won't go into that now. You'll do it when we do calculus. Alright, so just a basic tip. To memorize opposite of hypotenuse, adjacent over hypotenuse, and opposite of adjacent, we can say so, ka, toa. Where so means that sine would be opposite over hypotenuse. And cos would be adjacent over hypotenuse. And tan would be opposite over adjacent. So, ka, toa. Alright. There's many other ways they've made abbreviations of that to help learners memorize. In short, as I say, so ka, toa. If you memorize that, you should be okay. Right, let's look at the next slide. Right. So if you look here at the first problem given, they're given AB equals 7. So there from A to B is 7. BC from B to C is 5. And AC from A to C is square root 74. ACB, so from ACB, the letter in the middle always represents where the angle would be. ACB is theta, and PAC or PAC equal alpha. So PAC is alpha as indicated below. Alright, so we refer to this diagram above, and they'll always say this, and don't get scared when you read it. Without using a calculator, write down the value of 1.1 sine theta, sine alpha, cos alpha, tan alpha. Alright, so to get sine theta, I assume you remember, from our SOHCAHTOA, sine is so, meaning opposite over hypotenuse. They say theta, so I'm starting by theta, you see. So I'm reading from theta. What is opposite theta? 7. What is the hypotenuse? Square root 74. So opposite over hypotenuse is sine. So therefore my answer there is 7 over square root 74 theta. This one they gave alpha. So sine alpha, I have to start where the angle alpha is. So there I have alpha. From alpha, what is opposite alpha? 5. What is the hypotenuse? The hypotenuse is always opposite the 90-degree angle. So sine of alpha would be 5 over square root 74. Opposite over hypotenuse. So therefore, 5 over square root 74. Then they want cos alpha. So cos alpha, again, I'm working from the angle alpha. So I have to work from what's given. Be very careful of that. Go look at which angle we're working with. So if I'm working from there, cos adjacent, what is next to it? Hypotenuse always across the 90-degree angle. So katoa, ka adjacent over hypotenuse. So adjacent is 7, hypotenuse 74. So therefore cos alpha 7 over 74. If we say tan theta, from theta, tan is toa, opposite over adjacent. So opposite theta is 7. Next to theta is 5. Remember, square root 74 is across the 90 degrees. Therefore, that stays my hypotenuse. So opposite is 7. Adjacent is 5. And therefore, my answer is 7 over 5. So generally in exam, basically give you 1 mark for each. Some examiners, lenient, can even give you up to 2 marks. Alright, so this is just a basic problem. Next one I've copied from past exam, I think November 2015, but let's look at that problem. Right, so triangle PQR, there's PQR, and triangle SQR are right angle triangles as shown in the diagram below. PR is 26, PQ 24, QS equal 8, SR equals 6, QR equal 10, and PRQ equal theta. Refer to the diagram above and without using a calculator, write down the value of tan P, sin SQR, cos theta, and sec SRQ. Right, so that's the question. Right, now you see the drawing there. Can confuse some of you. So there, I assume you can see PQR is a right angle and they say SQR. So to solve the problem, if you're stuck and you can't see or separate this in your mind, then just draw them separate. It works easier. But I'll show you what I've done in the next slide. Right, so refer to diagram above and without using a calculator, write down the values of tan, sine, cos, and sec. So remember, we're working with katoa. Sine being opposite over hypotenuse, cos being adjacent over hypotenuse, and tan being opposite over adjacent. Right? So they say tan P. So there's my angle P. If I work from P, remember tan is opposite over adjacent. So from P, opposite is 10, and next to P is 24. So that's 10 over 24. And 2 goes in 10 5 times, and 2 goes in 24 12 times. So that simplifies to 5 over 12. All right. Then they want sine SQR. So SQR is this angle here. They want the sine of that angle. So we work from this angle, sine being opposite over hypotenuse. Opposite is 6. Hypotenuse always across the 90 degrees, so that would be 10. So from there, 6 over 10. 2 goes in 6 3 times, 2 goes in 10 5 times, so therefore simplifies to 3 over 5 or 0,6. 2.3, they want cos theta, so I assume you saw in the previous drawing, theta is in this slide here. So if we work from theta, theta there, we want cos. So cos is adjacent over hypotenuse, A over H. So adjacent to it is 10. Hypotenuse always across the 90 degree angle, in this case 26. So cos theta here equal 10 over 26, which then simplifies to 5 over 13. So if you punch just like that in your calculator, 10 over 26, and press equal in your calculator, it should simplify to 5 over 13. Gives it a decimal and you have a Casio, you'll see there's a S D letter on your calculator. From standard fractions to decimal fractions, etc. So if you press that, you can convert from decimal to standard, and if it doesn't want to still, then press shift and S to D. Alright. Then they want sec. Now I assume you remember sec is 1 over cos. So if cos is adjacent over hypotenuse, then sec would be hypotenuse over adjacent. That you should have learned in the previous topic. If you don't know, then go to trigonometry. Alright, so they want sec SRQ. So SRQ is this angle here, right? So the sec of that, I want hypotenuse, which in this case is 10. And I want adjacent. So adjacent is 6, which is next to it. So it flips around, so this would become 10 over 6, which then equals 5 over 3 if we simplify. Alright, so hope you follow, hope you understand. As I say, if you want to go back to the previous problem, stop, look, write down the question, solve the problem on your own, come back, look at the corrections that I've explained, see where you've gone wrong. Take a different color pen, write down your error. Once you've identified your error, now you're going to try to do the sum again on your own till you stop making the error. Once your brain knows why you've made the error and you know more making the error on more than one occasions, then technically it's in your head. So our teachers, when we were at school, they made us do that. We had to do a problem 5 times over, and if in the 5 times we make no errors, then only we know the sum. But once we know it for life. Right, so yeah. But I know you're going to put in the effort and remain resilient, and you're going to achieve great results. You're going to continue improving. Right? Wish you nothing but the best. God bless. Bye.